Find the derivative of y equals x to the 6 minus 3x to the 4th plus 4x squared minus 8 all over x to the 4th. Then evaluate y prime of negative 2. Y here is the quotient of two functions, x to the 6 minus 3x to the 4th plus 4x squared minus 8 all over x to the 4th. And therefore, to take the derivative, one option is the quotient rule, but since we have a single term in the denominator, it's not added or subtracted with anything else. Another option is to take the quotient directly by putting each term in the numerator over that denominator and simplify the work needed for the derivative. Let's do that. We can separate each term in the numerator over that denominator, x to the 6 over x to the 4th minus 3 x to the 4th over x to the 4th plus 4x squared over x to the 4th minus 8 over x to the 4th. We have x's in the numerator and denominator. We can combine these by, because of the division, subtraction of exponents. That means we will have x to the 6 minus 4. We have a minus 3 x to the 4 minus 4. Or you can cancel out the x to the 4th if you like. X to the 4 minus 4 will be x to the 0. You'll get the same answer either way. X to the 0 will be a 1. Plus 4 times x to the 2 minus 4 minus 8 times x to the negative 4. There's no x in the numerator to subtract it from, so it just moves up to the numerator to be a negative 4. 6 minus 4 is 2, minus 3 x to the 4 minus 4, which will be x to the 0, and x to the 0 is equal to 1, so that'll be just a minus 3, plus 4x to the 2 minus 4, which is negative 2, and then minus 8 x to the negative 4. At this point, we have terms that are combined by addition or subtraction, and therefore we can work out their derivatives separately and combine the results by addition or subtraction accordingly. So let's now take the derivative. Each of these terms will follow a power rule, except for the second term, which is just a constant. Y prime, which can also be called dy dx, equals, the first term is power rule, bring the power down, subtract 1 from it, 2x to the first power. The second term is a constant, the derivative of a constant with no x's is just a 0. The third term is a power rule, bring down the negative 2 times the 4, negative 8x to the minus 2 minus 1 more, which will be minus 3. And the last term, bring down the negative 4, multiply it times the negative 8. That'll be a positive 32. And then x to the minus 4 minus 1 more, negative 5. Since I have negative exponents, I'm going to rewrite those terms, move them to the denominator to make them a positive exponent. So I will have 2x minus 8 over x cubed plus 32 over x to the 5th. Another positive exponents. That'll make it easier to plug in when we evaluate. So there's our derivative. The next thing is to evaluate y prime of negative 2. That means to plug a negative 2 in for each of the x's, so 2 times negative 2 minus 8 over a negative 2 cubed plus 32 over a negative 2 to the 5th. 2 times negative 2 is negative 4 minus 8 over negative 2 cubed. Negative 2 times negative 2 is positive 4 times 1 more negative 2 will give us negative 8. Plus 32 over negative 2 to the 5th. Negative 2 times negative 2 is positive 4 times a negative 2 is negative 8 times another negative 2 is positive 16 and times the last negative 2 will be negative 32. Now the 8s can cancel and the 32s can cancel, and those will be 1s. Just be careful with the sign. We have a negative in the denominator for each of those. So I will have a negative 4 The double negative will give us plus 8 over 8. And then the plus and minus will give us a negative 32 over 32. And these can cancel down to become a 1. These can cancel down to become a 1. It looks like we have for y prime of negative 2, a negative 4 plus a 1 and then minus a 1. The positive 1, the negative 1 can cancel, and therefore it results in negative 4.